Hello and welcome everyone. Thank you all for joining us today for this live stream event. My name is Rebecca and I'm the event planner of the Microsoft Reactor New York. Before we begin, I'd like to quickly review two items, our code of conduct and our event guidelines. Also, you'll see on our screen the login for our check-in page where you can find some resources for today's session. And I'll share that in the link with you. So our code of conduct, Microsoft Reactor seeks to provide a respectful environment for both our presenters and our audience. So please, we welcome engagement in the chat, but please be mindful of your commentary, remain on topic and professional. This session will be recorded. You will not appear in the video. The recording is uploaded to the Microsoft Reactor YouTube channel for on-demand access at a later time. It usually takes about 48 to 72 hours for that video to become available. I'll share the link to our YouTube channel as well, just in the chat in a moment. If you have any questions, again, the chat is where you can ask questions, interact with the rest of the audience and the presenter. If you are using YouTube for the first time for a live session and you haven't had to use the chat before, you do need to set up an account. So if you haven't done so, now would be a great time to do that quickly. And then you'll be able to interact there. If you're not able to ask those questions, if you don't have the chat set up, you can feel free to reach out to myself directly as well after the session completes. If you joined us through Meetup, you can message the Reactor program manager for your local meetup and just say you attended this session, you had these questions, you'd like to get them answered, and we can always follow up with the presenter at a later time. Today's session is data on Azure, what, when, and how. We are joined today by Michael Yufit, a cloud solutions architect at 2B Cloud, which has been wonderful with partnering with us on a number of sessions over the last couple of months. So we have some of those sessions available on our on-demand as well. If you haven't done so yet, definitely check out the other ones. I'll share links to them as well. So at this time, I'll bring up Michael to the session. Hey, Michael, welcome.
Hey, good afternoon, guys.
Thank you for joining us today. We already have a lot of people in the room, so that's great. I'm going to, do you want me to pull your slides up?
No, I'll just share my screen. Thank you. Okay. Okay, thank you very much for having me. Just
oops. Oh, your slide stopped sharing there for a second.
Okay, I'll share it once again.
Sorry about that, everyone.
No problem.
Okay, let me add it back up. Technical difficulties. Okay.
Yeah, so good afternoon, everyone. Today we'll go through an introduction of different types of storage offered in the Azure cloud and when and how to use them. Enjoy the lunch and thank you for joining. I'm Michael and I'm a cloud solutions architect at 2B Cloud. My role is about helping clients with cloud adoption, cloud migration, and running optimized workloads in the cloud. I'm based in Canada, Ontario, and in my personal interest, technology, travel, and soccer. Before we dive in, quickly about us. We're a Microsoft partner specialized in networking with tech companies. We're an MSP expert with advanced specializations like Windows and SQL Server migration, Kubernetes on Microsoft Azure, modernization of web applications in Azure, and Azure ISV specialist. Today, we will cover in a high level Azure Storage account and its services, SQL databases on Azure. We will touch in a very, very high level NoSQL database services, and we will see some of the items in action. So understanding Azure Storage is a fundamental building block needed to start building a successful cloud practice in Azure. So what is actually the storage account? A storage account is a collection of 5 services that store all the data objects in Azure, like file shares, blobs, queues, tables, disks, etc. And it is accessible from it is actually accessible from anywhere in the world over HTTP or HTTPS and API. The data in the storage account is durable and highly available. It's secure and massively scalable, up to petabytes, and it has the following 5 services. The blob, basically any kind of unstructured data can be blob, which stands for binary large object. Basically any type of file. It's designed for applications and users to work with any unstructured data in the cloud. The file storage is very similar to Blob. The major difference is in the way you access the files. It is designed to share drives between virtual machines and to extend the file shares from on-premises to the cloud. It works with Windows, Linux, and macOS. The Azure Queues is a very small service that's designed for applications. It can aggregate messages and allow other services to pick those messages and to process them in a queue. The table, designed to put a semi-structured data forms into tables. It is a fast and schemaless and referred as a NoSQL database. And last but not least, this is Azure Disks. Basically, those are the VHD files that are attached to virtual machines as a disk. And it comes with different availabilities of performance and the management tiers. So if we will create kind of 2 groups and like 2 main groups and to try to divide those types of storage to them. So the queue, the table, and the blobs, they're mostly developed they're mostly designed for developers and for the application. Therefore, you can access them via REST API and SDKs. And the file storage and the disk storage, they're mostly designed for working with the virtual machines and the traditional way of file sharing. If we're talking about the durability and availability, Microsoft Azure offers a few tiers of availability when let's just cover a couple of them, like local redundant storage, which basically means every file that you create in a blob storage or in any other storage, it will be replicated 3 times within the same data center. This will give you a durability of 11 nines. And this is going to be redundant within the same data center. The other one, for example, it's a zone redundant storage, which basically does the same, but now it will create a single copy of the file, but still 3 times with each one of the data center within the same region. And this one will increase your durability to 12 nines. The geo-redundant storage is actually a combination of the local redundant storage. When you create a file in one data center, it will be replicated there 3 times, but then it also will be replicated to another geographical region, which can, for example, be US East or US West, and this copy will be replicated 6 times in Azure, and this will give you 16 nines. And the last one is actually a combination of zone redundant and local redundant, which still will give you the 16 nines. So we have a different storage tiers. They basically allow to provide a better performance and better pricing right for the need and the task. The hot tier is designed for frequent access and provide low latency in accessing the files. And when we're talking about latency, we basically refer to the time to the first byte, and it happens in milliseconds. Um, If you need access the file, let's say once in a while, but you need it right away, then the cool tier is exactly the right tier for you. So we have some constraints with this because the cool tier is designed for infrequent access and the price per gigabyte is going to be lower. However, it's going to be the higher access and transaction cost. And the data in the cool tier should remain for at least 30 days. I, I mean, it will be built for 30 days. Therefore, you need to find the right balance where to put your files. The archive tier is an offline tier for storing data that is rarely used and accessed. Um, so of course that the archive access tier has the lowest storage cost, but the higher data retrieval cost and latency compared to the hot and the cool tier. So if in the hot and the cool tier you need to access a file, this file will be available for you in milliseconds. In archive, it may take up to 15 hours. The important thing to remember here that the minimum term of the data that the data must remain in the archive tier is 180 days, which means if you uploaded the file to archive, you will pay for at least 180 days for this capacity of the storage. Otherwise, you will be charged for an early delete fee. Which actually kind of brings us to life cycle, and I would like to bring some example maybe. So for an example, let's say that we have an application that is doing a document signing. Once the file accessed in the first time and the document is signed, we don't need it anymore for a frequent access. So therefore, we can move this document to the cool tier, just to be there in case we will need it in the nearest time close to the document site. But after, let's say, 30 days, we know that we don't need this file anymore because everything is fine, everything went through, everything is and everyone is happy. But now we still need to keep this file because we have some compliance that we need to keep this file for 2 or 3 years. So in this case, we just will create a lifecycle policy that will move the file from the hot tier after it was accessed once and signed to the cool tier. It will remain in the cool tier for another 30 days, just in case. And after the 30 days, it will be moved to the archive to be there and to complete the expiry period. And once the expiry period happens, we actually can delete this file. By the way, the life cycle. So when we're creating the files, there is an ability to create a file versioning, which means every change that you're doing in the file will be created will create another copy of the file, and this will be stored in the tier itself. But once you delete the file itself, the life cycles rule, they also will delete all the versioning of the files. So once you deleted the file, that means that you will delete the entire versions of the file. In terms of the security, Azure provides a holistic framework with lots of capabilities and recommendations. Everyone can find the right method for his use case and to sleep well. The important thing to keep in mind that this is a shared responsibility model. Azure provides the tools and the framework, and you as the consumer are responsible to configure and manage it, which means a very simple thing. Your house has a door, but you are responsible to lock it, right? So Azure has many ways to protect the data, and it can comes to something like uh, alerts and tracking, as well as auditing. It can be controlled based on the networking level, and you also can enforce a specific protocol like a TLS. You also can choose the version of the TLS. Either you want to go with 1.2 or with something that is already retired like 1.1 or 1.3. It is fully integrated with let's say different directories, because it's not only with Azure Active Directory, it also can be integrated with Active Directory, so and as well as it integrated with the Key Vault, And Key Vault is a Microsoft Azure service that will allow you to store password and basically manage and rotate those passwords in a very secure manner. It also provides different features to protect your data, such as Azure Defender, which is built into the service itself. Um, as well as we mentioned previously, it has a secure transfer, HTTPS, and you have different mechanisms like soft delete to protect your data against accidental deletion. So this is provide you everything that you need. You just need to write. You just need to uh, decide on your strategy and approach, how you'd like to protect your data, how you want to be compliant, etc., and how it works best for you. And then you'll have the entire framework to accomplish this task. Let's talk a little bit closely about the blob. So the blob storage can host any type of data object, as we mentioned previously. Blob simply means file. This is a very secure and scalable storage with which used um, a lot in applications and video streaming. This service is heavily integrated with almost all the services in Azure, and it stores data like logs, backup. It's heavily utilized by Azure Site Recovery Service to replicate the disks from on-premises, etc. You just name it. The service is a fundamental service and available in all the 54 regions, plus China and government. It's designed for supporting applications. Therefore, it can be accessed via API and different SDKs. Microsoft provide a very holistic way and very comprehensive libraries to insert data, to modify data, to pull, to fetch, everything that you just can think about. Um, it's very cheap and it's available in different redundancy and availability tiers. And the structure looks as it's presented on the diagram. So before you can consume the blob, first of all, what you need to do, you need to create a storage account. Once you're creating the storage account, you basically decide what kind of tier and what kind of redundancy, availability, security, etc. will be applied for this account. Once the account is created, then you can go to the blob part of the storage account and you just can create container. Container basically means a logical location where you can store your files. You can have multiply containers under one storage account, or you can have a single storage account, single container under a storage account. You also can access this data as you wish with upper level tools. And once you created the container, you can create or upload files within the container, and each one of the files has a metadata. This metadata used a lot for applications when you want to filter data, when you want to sort the data, when you want to do any other operation and manipulation with the data and files. The Azure files, this is, so the file storage is very similar to the blob, and the major difference is how the files are accessed. This is a fully managed file system in Azure with just a few clicks in the portal, you can get a file share like Windows, Linux, or Mac. There is no VM to manage, and you can use this file share for anything you normally use a file share. It's available in different performance tiers like SSD, HDD, of course, based on the need. So this is a service that is used for general purpose file sharing. It may be connected directly with your on-prem file share, and it also can work in a hybrid mode. Hybrid mode is when you can connect when you connect to the cloud share through a local file server. So basically, the hybrid mode allows it's acting as a cache server when users connecting to your on-premises servers to access the data that is located in the storage account. So you can install agents on the local file servers, and they will sync all the data between on-premises and the cloud. It is transparent for on-prem users, and the Active Directory still works. So we actually preserve all the permissions, and it's a perfect extension of your local file server. And of course, that users can mount the drives and whatever they want to do with the shares. So as I mentioned, the hybrid mode allows your on-premises servers to function as a cache, and you can grow the data in the cloud without extending the footprint on premises. And only the hot data is stored on-prem, but the majority of the files will still be in the cloud. In terms of the redundancy level, so you have the backup and restore. You can make an item level recovery, all the full share, and the backup performed in the cloud. So that means that you can get rid of all the third-party tools and reduce software zoo in your organization. And it's fully integrated with Azure Active Directory domain services, Azure Active Directory, and Active Directory domain services. So any type of the identity providers are integrated heavily with this service. And the way how you access these shares is actually through SMB3 or NFS. So as I mentioned, it supports Windows, Linux, and macOS. So the big difference between the Blob and the Azure files in the terminology that you still need to create the account when you decide on all the tiers and all the levels. Once the account is created, then you need to create your shares instead of containers, but then you just put the files. And if we're looking in a like high-level diagram of the solution itself, so in the center we have the Azure file shares. This is the actual share, which can be accessed via SMB3 or NFS. So clients can access the data and the shares directly from the internet, or they can connect via VPN to Azure network and then to access the file share. They also can access it from on-premises, however, it's not presented in the diagram. And as you can see, it's heavily integrated with your domain controller through Azure AD Connect to Azure AD. And if you need to perform a backup and recovery, so the recovery services vault is designed as part of the solution and integrated with it. It also supports scripting and tooling. So if you'd like to automate your environment and you have PowerShell scripts, and this is the way how you automate your environment, it's fully supported, it's fully managed, and just to conclude, we use it to share resources. Azure Disk Storage. This service is all about managing the virtual disks for virtual machines. Based on the required performance, you can choose the disk type that is right for you. This can be unmanaged or managed, and of course the unmanaged is managed by you, and the managed is managed by Azure. In unmanaged disk, you must create a storage account in resources. You must to create a storage account in order to hold the disk, the VHD file itself. With the managed disk, you are no longer limited to the storage account. So basically, you don't need to create. It's everything handled by Azure for you. And there are some restrictions on the managed disks, so feel free to go and explore to compare the options before you deciding what is the right for you. But my tip to you to keep in mind is if you have to decide between the managed disk or unmanaged disks, So the unmanaged disk has a URI to access the disk. And let's say in Azure, if some storage is going down, which means that you have manually to detach this disk from the virtual machine and then attach it to a new virtual machine. When in managed disks, Azure will handle this for you, and the virtual machine state will not be affected. So that's basically guarantee you that your virtual machine is always gonna be working, regardless any hardware failure or not. The other points in terms of the price, in managed disk, you have predefined sizes. And if the size of the disk that you need is way smaller than the minimum size of the managed disk, then in this case, just go with unmanaged as it's gonna be much cheaper. Um, so the managed disk has a better performance in terms of IOPS and support as well. Um, as you don't have to manage and you don't need to manage any storage accounts. And the conclusion from that being said is that for the production and the critical workload, you would go with the managed disks, and for the non-critical, the unmanaged may be the great option. Another thing about unmanaged disks, when you utilize a service on Azure that calls Azure Virtual Desktop, this is basically a service that is responsible for virtual desktop infrastructure, and you would like to create your custom image. In this case, you would need to create an unmanaged disk to create your golden image, and then you actually can collect the URI that is that basically is the link to the blob location and to feed it into Azure Virtual Desktop Service. Azure Queue. As said, the Azure Queue is a small service that designed for applications. It can aggregate a lot of messages and allows other services to pick those messages and to process them in a queue. The queue service is accessible from anywhere via authenticated HTTP or HTTPS calls, and the max size of the message is 64 kilobyte. The structure of the queue is very simple. You still need to create the storage account. Under the storage account, you just can create the queue. And on the diagram, you can see the queue messenger as a store, as a messenger store between the front end application and the function app. So basically, the web application is pushing messages to this queue, and the function app just picking up them from here, and then doing what it needs to do. Azure Table. So Azure Table designed for developers. Um, so it provides rich client libraries for building applications with .NET, Java, Android, C++, Node.js, etc. And the data is also accessible via REST API, which is basically can be called by any language that makes the HTTP or the HTTPS requests. The table storage is excellent for flexible data sets like web app user data, maybe some card or address books, etc. And of course, that this service is all the other highly available and geo redundant, and this is very fast. And the key feature here is that this service is schemaless, and this is kind of a little brother of another service in Azure that's called Cosmos DB, which is the big brother of this one and allows you better capabilities, but they're both heavily for the developers. And of course, in terms of the structure, so you just can create your storage account. Inside the storage account, you can create a table. And this is the beauty. So as many types of data that you have, because it's semi-structured, you can just create as many tables as you need. And inside each table, you just can create the files that you need to store the data. And by the way, this is a JSON file. This is an example of how the stored data looks like. Did I have a chat? 1 second.
We do have one question in the chat.
Okay.
So question, in the model of file sharing, would an SMB work via a web API the same way that an on-prem file system does?
Again, I'm sorry. Could you please repeat the question?
Sure.
Where is
So the
it?
question
Mm-hmm.
is in the chat, but I'll read it to you. In the model for file sharing, would the SMB mode work via web API the same way that the on-prem file system does?
Yeah, it has the completely the same capabilities and even better. So I specifically haven't done this, but yes, the answer is completely yes.
Right, no more questions so far. We can continue.
Okay, sounds good. And that brings us to Azure SQL. So I don't think that I need to talk about SQL. What is this? This is the most common database in the world. And let's talk about a little bit about the um, Azure SQL. So if you want to build modern applications with the highest uptime and predictable performance, as well as dramatically to reduce the operation side, then Azure SQL, this is the right service for you. Azure SQL Database is again a fully managed platform as a service, a PaaS database engine that handles most of the database management function, such as upgrading, patching, backups, and monitoring without users' involvement. The important thing to know about the service that Azure SQL Database is always running on the latest stable version of SQL Server Database engine, and it patched and it's available on 99.99%. So in terms of the availability, as a baseline, it's 99.99%, but it can go up to 99.995%. The past capabilities that are built into Azure SQL Database enable you basically just to focus on what you are doing and to completely remove this headache of managing databases from you. It's also a very popular service because, as we mentioned, it automatically applies the update and the patches. It has a very high degree of scalability. It has the point-in-time restores, which is a very important feature. It has a geo-replication NDR built in. It has a monitoring and threat protection as a built-in inside the service. It also supports the TLS and TD encryption. And in terms of the pricing, so this is a little bit interesting. And I just don't want to repeat myself with all the built-in default features that every service that's created in Azure is always in mind with scalability, security, performance tuning, etc., etc. But if we'll talk a little bit about the pricing and how the price model is working, so um, in terms of the server, either you're using the so so first of all, it has two main billing models. The one is DTU, and the other one is vCore. And in terms of the service, either you're using the DTU based model or the vCore pricing is absolutely the same. So there is no differences in how the server itself is act. It's just the way how you're paying for this. The DTU, it's actually the database transaction unit. It's a Microsoft term, and it's a blend of CPU, RAM, and I/O, and also the storage. It's a power unit of resources to run the database, and the more DTU you have, the powerful your resource is. So you actually can go with a minimum of 5 DTUs, and in the premium tiers, it can go up to 4,000 DTUs. It really depends on the size and the power that you need for your database. And the DTU comes together with the storage. That means as you grow your storage, you increase your DTUs. It comes together. So we can see it here on this graph. So let's say we need 100 gig, for example, then it will give you by default, like let's say 25 DTUs. You want to go with 200 gig, you cannot remain on the 25 DTUs, you must go to 50, for example. The vCore model is actually equivalent to the on-prem, so you know how much power your database needs, and you can apply the same model in the cloud. So let's say you're running a database server on premises, and you're using 4 vCore and 32 gig of RAM, and you still want to remain with the same model because you know that your power is predicted, and this is the way how you'd like to manage it, then no problem. So you just go with this. So one thing maybe about the vCore is that in the vCore, you actually are paying separately for the storage and separately for the compute. So if you decided to go with 2 vCore and 16 RAM, but you know that your database is relatively small, like 10 gig, that's fine. You can decide what type of size you need for your database. And that way, you have more flexibility to manage it compared to DTU. Of course, once you provision your database, you can switch between the models after the provisioning, so you don't really need to worry if you didn't make the right choice in the beginning. That's fine. And there is also a new option that is available now. It's called the serverless option. And I more will speak about this in the demo itself, because this option actually will allow you to decide on the minimum required resources, on the maximum required resources, and if you are not using or consuming your database for, let's say, for 1 hour, in this case, it's gonna be non-chargeable. So you're stop paying. And of course, like in terms of the security, I didn't mention it, but security is a built-in capability inside the database. Um, you can have like a private link and public link, etc. Highly available with different availability zone, etc. The building blocks of um, of Azure SQL is actually the server itself, the database, and the pool database. Let's quickly talk about them because we still have to run a demo, and I see that we're kind of running out of time. But the server itself is um, a entry point where you're managing everything related to the database, like firewall rules, backups, tasks, failover groups, auditing, threat protection, authentication. Every time when you're creating a single database in Azure, you're basically creating two objects, because the database itself cannot just run somewhere. It is running on the server itself. So every time when you're creating a single database, you will create it together uh, with the server, with the SQL server. And if you want to manage everything from this scope, for example, you will need to go to the SQL server. If you want to do tasks like directly related to SQL, then you can go to the database console and to manage it from there. So the database is actually, each database is isolated and portable. You can move it from one server to another. And each database has its own service tier. As we discussed previously, it can be DTU or vCore or something else. And then we also have the possibility, the option that's called pool database. The pool database, it's a um, simple, cost-effective solution for managing and scaling multiple databases, which basically means, let's say that you have many different small databases, and you know that each one of these databases are doing some transaction or some query once in an hour, and you have many of them. So instead of creating 4 servers and to manage them, you actually can create a pool that will share the same infrastructure to run all those databases. And if you're looking here, so let's say that that you decided that your DTU is going to be 90, and you know that your peak is 90. So basically, every other databases that's running on this resource are still under 19. So that means that, and you have like someone spike here, someone spike here, but in general you don't. So even if you take like this database and you will connect them together, you still get 60 DTUs. So the purpose here is actually to take many small databases or databases that are not have a very heavy or they don't need a dedicated server, and just put them in one shared hardware, and in this way you can just reduce the cost. And of course you can uh, attach database, you can remove it from this pool, etc., etc. You have the entire flexibility, because if you remember, we just discussed the database, it's an isolated and portable. In terms of the deployment options, how you can deploy the database in Azure. So one of the options, the first one is the SQL database. And when will you use that kind of database? So if I want to build a modern application with the highest uptime and predictable performance, this is the thing for me, because it's a single database. I don't need to manage it. It's fully managed. It's serverless for me. It's hyperscale, and I just can get it. The same thing with the Elastic Pool. So I'm just focusing on the databases. I'm not focusing on managing the infrastructure. The other way of deployment is a SQL Managed Instance. So this one, the best scenario to use it if you want to migrate to the cloud. It still removes so if you want to migrate to the cloud and you want to remove the management and the operation overhead, but you need machine scoped features such as a service broker, maybe agent, maybe CLR. In this case, you will go with the managed instance because this will give you those richer capabilities, as well as this one is natively integrated with the networking. And it also integrated with on-premises identities to enable Azure AD Connect, to enable Azure AD integration. And of course, it's a fully managed service, and it's also very good for lift and shift. The other deployment option, it's just a SQL Virtual Machine. So when you need a classic approach of managing your database, the SQL Virtual Machine may be an option for you, and it actually gives you SQL Server and OS level access, when you can connect to the server to do what you need. Maybe you have some legacy application, you need to run some scripts, you are doing it as a POC, etc. So, and one of the way is that you don't need actually to go and to deploy an operating system like a simple virtual machine, then to go and to download the binaries for the SQL server. You basically just can go here and to select from the predefined images, and here you have a different type of operating systems, and it will include operating systems such as Unix and Linux, and you also can combine it with different SQL servers versions, as well as you can bring your own license. So if your company already have invested in licensing and you still would like to use this license because it will dramatically reduce the cost, so why not? You actually have this option here. And that brings us to the last item for today's presentation, which is the Cosmos DB. And we will really touch it in a very high level, just maybe a couple of words. So first of all, I'd like to start from that the Cosmos DB, this is really for the developers. It's for the applications. It's designed for support different type of application. This is very massive. This is very scalable, super highly available, very low latency, very fast. And similar to Azure Table, it has no schema or index management. Of course, that you can manage the indexing, but Azure does it for you. It supports different APIs such as Core SQL, MongoDB, Cassandra, Azure Table, and Germlin. So it's actually a key value storage pair. It's a JSON file when you just create a syntax of JSON. It's also one of the reasons why it's so fast. And this is referred as a document DB because you basically store JSON files. This service is available in almost all the regions. It's a fundamental service. It's a very well documented service. Because it's so popular and integrated in so many applications, many materials are available and a lot of use cases. And it also integrated with Azure Key Vault and can work with another services in Azure, as well as it can be deployed manually, it can be deployed automatically using infrastructure as a code, etc. And I will jump now to a demo. Let me please bring up here.
So while Michael is switching to the demo, I just want to encourage everyone, if you have any questions, feel free to write them in a chat and we'll of course answer them.
Okay, so we are here in the Azure portal, and I'd like to start with Blob. So as the first thing, what we need to do, we just need to find the service, and the service is called Azure Storage account. It can be accessible in the quick access bar, or you just can search it here. So let's just jump in. In the storage account, first of all, we need to create one. So once we're creating the storage account, let's create a resource group and call it demo. Everything that you are creating, you put it in a resource group. A resource group is a logical way of structuring your resources in Azure. We'll give it some name. This name is supposed to be unique. So I'll just pick something like that really is not going to be available. Then we would need to decide on the region where we are deploying our storage account. The next thing, if you remember, we talked about the different performance here. So we have the standard and we have the premium, which basically means the premium, this is for scenarios that requires low latency. The standard is for more standard thing. So just for the demonstration, we'll stick with the standard. And in terms of the redundancy level, these are the 4 types of the redundancy. For this demo, we'll stick with the local redundancy type. Then we'll go to the advanced configurations, and it brings up to the security. In the security, so we have the option require secure transfer for REST API operations. You just click. So this is one option. Enable infrastructure encryption, which means you can encrypt it, enable Blob public access, which means is this storage account may be accessible from the internet or not. Storage account access keys. So exactly as it says here, when storage account key access is disabled, any requests to the account are authorized with shared key, including share access signature will be denied. Then it can be integrated with Azure Active Directory. For now, we just will skip it. And here is the minimum TLS version that is actually required. So we can go with something old, but let's stay with something new that is not compromised. So if you want to use Azure shares in SMB3 profile, you need to enable the namespace. We just will skip it for now. So the namespace is actually used for the file servers. Do I have a question? Okay, and in terms of the tier, we discussed the hot and the cool tier. So the hot tier, that means that the files are frequently accessed, can be deleted anytime. This is the most expensive in terms of the per gigabyte, but the lowest cost per transaction and accessing, and the data available immediately. So then we'll use this one. In terms of the networking and the connectivity method, we just will go with the public endpoint just for the demonstration because I'd like to show something. And the routing preference, it can go through the internet routing or through the Microsoft network routing. Depends on your network design, but in this case, we just will stick with the default. Then we have the data protection, and here you have some controls that you can enable or allow in order to protect your data. So you have enabled point in time restore for containers, which means you can restore the entire container if you deleted it or something happened. Same with the soft delete blobs, which means it's deleted, but it will be archived in the recycle bin, and you have a better capabilities to restore your files very quickly. How much time do I have? Okay, so same for the file shares and same for the soft deleted container. And in the tracking, we talked about the versioning a little bit. So versioning is another copy of the file that is created once you make any modification of the file. So we just will stay with everything default just for now. And this is the way how you're actually creating a storage account with different levels of performance and tiering and security and whatever you need for this particular container. And once we will create it inside the container, we will have our storage services. Let's give it a couple of minutes.
Michael, if you run over by a few minutes, that's okay as well. It's not an issue.
Sure, sounds good. Okay, so now it says that the storage account was created. It's still being created. The deployment is in progress. And now it says that your deployment is complete. We can go to the resource itself. There is a couple of ways how we can access this resource, but we're right now inside. So as a general and the overview section, you can see all the information that is actually a metadata about your storage account, such as the tier, the replication type, the account kind, the provisioning state, when it was created, subscription ID, etc. Some of this data you can use inside your API calls because this is the way how you actually talking to it. And in the bottom, we have the 4 services like Blob service, file service, queue service, and table service. So when we started the presentation, we talked about 5 different types, and the 5th type is actually the disks, the Azure disks, which is a standalone and in a separate pillar. So let's see how we can create a container and to create some files. So let's assume that this is our storage account, and now I would like to start with a new container. We just will give it some name, like let's call it Monday. I don't know, Monday 1. Yeah, of course. Okay, then we can decide, is this container gonna be public or private? But because we said that we want to make it public, and for example, many of the applications are utilizing Blob to keep the pictures for the website. So the website doesn't, so when it has the path for the file itself, it's actually going directly to the Blob and pushing it from there. First, because it's available very fast. Second, it's available from anywhere in the world, right? And third, it has the complete API and it can talk almost any language, so it's going to be accessible. So in our case, we just will go with the anonymous. So everyone will be able to access it, and we'll skip now the encryption, and we'll create our container. So once we are going to the container itself, now we can go and upload some files. And just for instance, let's create quickly a file. Okay, we're saving the file and going back to here, and we would like to upload this file now, so we just can navigate. By the way, it can be done through the web browser as we see it now, but of course usually you don't upload the files manually, you push them through some script, through some API, through something. It's seamless for the user. You just treat it as a storage where something is when you incorporate it inside your application. Okay, so this test file, because it's public and it's available, so I'm just taking this URL and I just will paste it in the chat. And you can just go click and open this file. 1 second, if I will find the chat. Here we go. Okay, so you can try to download or just to open the file. And also it inherits different permissions and different settings from the storage account itself, such as the tier like hot, etc. Yeah, let's delete this and let's jump on to something a little bit more interesting. And I'd like to demonstrate another service from Azure account. And now we are going to file service. So the file service, this is a shared drive basically. First of all, we are not configuring it, but this can be configured to work with Active Directory. Okay, and it says Active Directory, which is your on-premises Active Directory, or we have AADDS, which basically stands for Azure Active Directory Domain Services. This is the SaaS service of Active Directory in the cloud, and it's heavily integrated with Azure AD. We're not doing this just now because we don't need it for now, but then we're just creating a file share, and we'll give it some name. And let's say if the previous one was Monday, this one is going to be Friday. And that was Monday 1, this is going to be Friday 2. Here, in terms of the tier, how you would like to get it. So again, we have transaction optimized, we have hot, and we have the cool. The cool is for archiving. The hot is optimized for general purpose file sharing. The transaction optimized, this is if you have like a very heavy files, but you don't need them like fast, and you allow the low latency, then this is the option for you. So here we just will stick with the hot. We'll create the file, and the file is created. So as I said, in a couple of clicks, you created the file share. But now how can you access it? So once you click on the file itself, let's, by the way, create a couple of folders here, and let's say demo1, and no, let's say demo. Yeah, okay, let's keep it as demo1, and let's add it. And let's add another folder and call it demo3, for example. And now would like to connect this file share to somewhere. It's actually any client in the world. So as I mentioned, we have Windows, Linux, and Mac OS. If it's a Windows, so you need to decide what is the drive letter that you would like to create these shares under. So let's say that we're creating something under O, and we're not integrating at the moment with Azure with Active Directory. Then it just gives us a PowerShell script. We copy paste this PowerShell script. We just open in a PowerShell window at any client. And again, as I mentioned in the beginning, it can be completely automated because you can run it through a group policy, you can create a logon script, etc. Then we're just running this simple script in the PowerShell. It did created the share, and if we will open our computer, so we can see here Friday 2, and Friday 2 has these two directories. And if we're going to demo and we want to create a new file, and it's going to be test2 in our case, that's it actually. So now the share was created, and this is as simple as is. And here is our file. So you can work from your local computer, but you will see the data directly in the cloud. You can make many different optimizations how you manage your data, because sometimes you have some data that is hot right now, but after a week, it's not required anymore. Sometimes you know that you have some cyclic tasks that you need to do, like payrolls or something else, and you'll need to pull some files to be available for the users. So anyway, if the file is stored in the cloud and you're trying to pull it, so if you will have a local experience of file share, that means you're accessing the file from your local area network. That means that you will get this file in milliseconds. So if this file is just like not cached in the local server, but it's sitting in the cloud, that means that first of all, this file will be downloaded to the server and then pulled to you. But because it's done very fast, so this file, instead of milliseconds, will be available for you in seconds, let's say. But the management of managing the operating system and the patches and licensing and many other things, and maybe to go and to buy new hardware, etc., and to invest in new storage, it's just not there. It's just gone. And many times today, many users are not working from the office; they work from home. So they have these shares already in place, right? And instead of going to on-premises network and very slow to pull up these files, they are directly connected. So the files are available to them in seconds. And if you noticed, many of you, I believe, using OneDrive. So OneDrive uses the same strategy. So it has the icons of all the files in the server, in the local folder on your client machine. But in fact, most of the files are sitting in the cloud. So only the files that you accessed recently or you clicked on them will be available as a local copy on your machine. And if you don't use them for some amount of time, they just will be residing in the cloud, but not on your local machine. And this, of course, allows you to have much smaller footprint on premises and dealing much less with the storage. And let's jump quickly to the SQL Server. And this is probably going to be the last thing for today because we're really running out of time. But by the way, yeah, so the disk, as I mentioned, it's coming as a standalone service, as a separate service. So once you are creating the disk, you are still going through all the same steps like the disk size, the premium, not premium, availability zone, redundancy, region, etc., etc., etc. You configure it, and then you can just use it and attach to a machine. One of the thing about Azure Disk, which is unique only to Azure, and this is the key differentiation key for Azure compared to any other cloud provider, is that a managed disk in Azure can be shared between multiple virtual machines, which is not available at any other cloud.
Michael, before you continue to the SQL Server, we have a question.
Yep.
So the question is, would the file storage be functional for a CI/CD pipeline?
Yes, of course. Yeah, it's absolutely, yeah. You can integrate it. Exactly. It really depends on the CI/CD pipeline, right? But if your CI/CD, like using some scripts and everything, it's totally can uh, using this resource as part of the CI/CD pipeline.
Thank you.
Problem. And jumping to Azure SQL, a couple of things here. So first of all, the deployment models that we had discussed previously, and just a quick about SQL virtual machines. So this is the way if you want to create a virtual machine with operating system access level. And in this case, for example, if you want to run your server on some Ubuntu, for example, because this is what your DBA knows, okay, here we go. You have a different Ubuntu servers, different versions, of course, what is available here, okay, and the different versions of the SQL Server. Let's say you have a legacy application, you're still running it on SQL 2017, etc. So here we go. You have it available for here. Let's quickly create a database. Absolutely in the same way, we just will need to put it in some resource group. In the beginning, just to select a subscription and give it some name. Okay. And then we're selecting a server. Well, we don't have, if you remember in the beginning, I said that once you're creating a database, you first of all need to create a server object because it needs to run somewhere, right? And because so now I'm trying to create a database. So it is looking into my account and say, hey, you don't have any SQL server, and therefore it will redirect me to create a new one. And once I will have this server, then I will be able to go and to create the database. So we'll give it some name here as well. Let's call it demo Friday 1, 2, 3, 4, 5, 6. Okay, then of course, in terms of the authentication, we can use a SQL authentication, which means this is a local authentication to the server itself. It can be integrated with Azure Active Directory, or it can be mix and match between both of them. In this case, we just will go with the simple option, and we'll just create some account, SQL admin, of course, without no spaces. We'll give it some password. Okay, password not much. No, much. Okay. All right. Then it will ask you, would you like to use this database with the Elastic pool? No, we don't. We just want to create a single database at this point. And then it comes to the compute and the storage. And this is actually the most interesting thing where I would like to spend all the rest of the time, because the server itself, regardless how you build for it, it's still going to be the same. You'll see all the same options like backup, security, database management, recoveries, etc., etc. But what is interesting here, so we start talking about so the vCore model, right, which is very similar to how you're using databases on premises. You just need to select your vCore, you need to select your RAM, etc. So let's maybe go through one of these examples. So here you go. We have, let's say that this is our server, and we want to have like 8 gig, okay, and we want to have only 2 cores, and then we can make it more redundant or less redundant, and this is our compute power. Then we know that this is very predictable. This is exactly what we use. This is what we need to have. We also can go with the different tiers. So different tiers will provide you different performance, like depends on the number of cores that you need, and you can say that like one is like for local needs, one is like more for enterprise, one is more for like scalable and really heavy workloads. But let's just stick with this one. Then the other option here, okay, sorry. So the other option is the DTU. So the DTU actually says that the 5 is the basic. This is what you have. So if you want to have a very small database that comes with only 2 gigabyte of data, then you will get the 5 DTU. And let's say you say, no, I'm having much bigger database. It's about 70 gig. Okay, then we need to go with something else. So DTU. So let's say we want to have 50. Oh, no, I said 70. Okay. Oh yeah, because it's because of the DTU. So as I mentioned, if you're growing in the DTU, so the storage and the DTU are coming together. You need actually to increase them. So let's say I want to go with this one. You see, it increases automatically the DTU. It's not something that I have a control over it. And the other option, which is the most interesting, it's actually the serverless. So why this option is interesting? First of all, because you might have an application or just a local database that sometimes it's used, sometimes it's not used, and probably 9 p.m. to 8 a.m. it's not accessible at all. And in this case, you just don't want to pay, right? You still need the database, but you are not using it. So why would you pay? In other case, you maybe have some database that is again is a design for some cyclic tasks, like to do something once in a month, once in 3 months. So you want to keep the database. You don't want to all the time to kill it, to create it, etc. But because you're not consuming the resources, you just don't want to pay. So in this case, what it's allow you to do, it actually says you, okay, no problem. So in this case, please define what is going to be the minimum required cores that you would like to have for your database. And you say, you know what, the minimum, because there is no transaction and nothing in there, half is going to be enough. It's much more sufficient because it's 0 transactions, 0 queries, like nothing. But let's say if you have some spike, like now all the users, 9 a.m., everyone decided to log in. You have a very heavy stream of transactions. In this case, you have a big spike and you say, you know what, now I want to have it like 8 cores. It's going to be sufficient for my need. Okay. And of course, as this number grows, this number grows as well, but not dramatically. And same, the memory is actually decided for you how you will be consuming the memory. So if you'll do a correlation, the 1 vCore will be correlating with 3 giga, and 8 cores will be correlated with the 24 gig, and everything between them. And then you say, because this database is not accessible all the time, and my goal is to reduce the costs and to operate this in a modern manner. In this case, I would like to enable the auto pause of the database, which means I'm just telling the system that if this database is not accessible for 1 hour, or there is no transaction, no queries, nothing during 1 hour, then just pause it. Once it's paused, you are not paying. And the first query that it comes in, okay, it automatically immediately invoke the database, and you are just start paying based on the CPU usage, because this is absolutely dynamic. Compared to the vCore model, you're allocating all the resources, but here is absolutely dynamic. So you have the minimum level and you have the maximum level. So with the first transaction, it will start billing you with 1. But if the first transaction was heavy and it's consumed 3 vCores, then you will pay according to the uh, 3 vCPU. And same with the storage here, it's very flexible compared to the DTU, because in DTU it comes together, the DTU size amount comes together with the storage amount. In this case, you're flexible to decide. And of course, redundant, not redundant, how you would like the redundancy for your option. So now, how does it build? So you have a compute cost for vCore per second, and it is gonna be something like this. So you see it here in the Canadian. In US, it's a little bit lower. Okay, but basically, this is the estimated. So here you are paying separately for the storage, and the storage for this amount, and this is 263 gig. It's gonna be 50 bucks a month. Okay, if you reduce the size, then your storage is gonna be cheaper. But this one is always remains the same, and it's always correlating to the lowest unit. And there is a table how exactly to calculate, but playing with all the options around, it looks like the DTU and the vCore, they are dedicated for very predicted loads, therefore they are provisioned. And the serverless, if you have something spiky, if you have something that is not predictable, etc., this is going to be the best option. However, it always needs a better analysis and deeper questioning what is the right size for you. The good thing is, as I mentioned, once you created the database and you now decided that, okay, so this database is going to be retired because we're not using it anymore as often as we used in the past. So in this case, you just can go and switch the model and dramatically to reduce this cost. And one of the things which is really fundamental in any cloud is it's not only to provision the resources, but also to manage them, and to manage them in an optimized way, because everything in the cloud that is idle, you're still paying for this. And with this being said, I'd like to thank you for watching, and let's go to the next slide.
So we actually have 2 questions. So the first one is, when saving a new version of a blob, is the billing doubled, or is it only for the different data between the two versions?
Okay, so if I understand the question correctly, if we have an original version of the blob, of the file itself, and then you're creating another version of this file, let's say that the first version was 25 kilobyte and the other one was 26 kilobyte, right? Yeah, so in this case, you're paying for both. It's actually you're paying for the storage.
Okay, and we have another one. Azure Disk Storage attached to multiple VMs, question mark.
Mm-hmm. Yeah. Yeah, so the same disk can be attached to multiple virtual VMs. There is a very specific use cases why you would use it, but it still give you the capability. So let's say you have two virtual machines that are running, and they both have the operating system installed on the virtual disk 0, and then you would like to mount this another virtual disk to both of them, and basically from both of the machines you will be able to look at this disk. Yeah, it's not very common used, but it's still available. I personally have never used it, but this is something that is available, and I heard of people that are using this. I don't know exactly what was the case for them.
Great, and just going back to the previous question, when saving a new version of a blob storage, so Offer is asking, does it even 1 byte is change, it still costs?
Yes, because you're paying for the total aggregation of the files. 1 second, I just will bring it up. So pricing, it's a pricing. I'm not always remember it, but let's just open it and bring it in front of us so to make it the most precise.
Michael, maybe because we're a little bit behind of time, you can share the link of the calculator, and that way anyone who has a question about exactly how can look there, and if they have further questions, feel free to send your email here and we'll reach out to you, get in touch with you, and explain everything you need in person.
Sounds fantastic. I'd like once again to thank you for watching, guys. And yeah, feel free to send me the questions. I'll share the link in a couple of minutes in the chat, and it actually will illustrate how exactly the versioning is built inside the Blob storage account.
Yeah, I'll share our email in the chat. So if anyone has any other question and they want to reach out to us or didn't have a chance here, feel free. We'll be happy to schedule a quick call and address any question you have.
Thank you both so much. Thank you, Eleni, for helping with moderating and with the chat. Michael, thank you again. This was a wonderful presentation. While we give the audience a couple more minutes to ask questions, and also you share the links, I'll just quickly ask the audience. I've shared the survey link in the chat. If you are part of our community, if you've consistently joined some of our sessions, we use the survey to kind of figure out who our audience is so we can target content toward that audience. So feel free to submit a survey, let us know a little bit more about you. And we appreciate any feedback that you can share. If this is your first time with us at the Reactor, we are an international program through Microsoft. We have a website, microsoftreactor.com. Feel free to check out our calendar there. We have physical spaces located around the world. So eventually with return to in-person kind of taking place, eventually there will be in-person sessions. If you happen to live nearby, you can find our locations on our website, also at meetup.com. If you're not a part of the Meetup community, definitely check that out. It's a great resource for developers. There's a bunch of community groups, all there, including the reactor. And you can search out a reactor that's closest to you so that you can find things within your time zone that make sense. We have a newsletter, aka.ms/reactor email sign up. We send that out just once a month with a big blurb for within your region, wherever you registered through, about what events we have coming up for the following month. That's all we send you about. And you can also follow us on Twitter. We usually post and highlight some specific sessions there. Michael, I'm just taking a look here. There's a question from an audience member about Azure Disk versus Azure File System. It's a follow-up. They had asked Azure Disk Storage attachable to multiple VMs, and then they asked, is Azure Disk versus Azure File System? I'm not sure if they need to clarify a bit more in regards to that question, or that makes sense.
If I understand it correctly, so the question is Azure Disk versus Azure Files, right?
Correct.
And
Yep.
Azure Disk is actually the actual VHD file. This is the virtual disk that attached directly to virtual machine. So in Azure, you have the virtual machines, and this is the disk that are attached to those machines. And you actually can control and decide what kind of virtual disk you will attach. Is it going to be SSD? Is it going to be HDD? What is the tier, etc., etc. When file shares, it's a logical service and fully managed service when you don't manage the disks as a disks, but the service itself guarantee you the SLA based on the tier that you selected for the storage account. So the data can be replicated in many different ways, depends on how you decided with which tier you had decided to go. And you're working only with the shares and with the settings and with the configuration of the security, of the integration with another Active Directory, etc. But in the disks, it's related only to the disks that directly attach to the virtual machines. That's the difference.
Awesome. Thank you so much. Also, just want to mention, I shared earlier in the chat our YouTube channel. So I would say probably about 95% of the sessions that we do live, we put out on demand within a few days after the session concludes so that you can revisit anything that's covered. So including this session, it will be available there. If there's something that you missed, something you want to re-reference, feel free to check out our YouTube channel, the Microsoft Reactor YouTube. We have some, here I'm just going to share a link to.
I had the link, yeah, for the versioning overview. So that will include everything in much more details.
Thank you so much, Michael. That's great. Yep. So I think at this time, it looks like we've answered all the questions. We've shared some information to you. If you have questions in the future, you can always reach us. The reactor, one of the better places is, again, as I mentioned, on Meetup, but feel free to reach out directly through our website. And at this time, I think we'll call it a wrap. Thank you again, Michael. Eleni, these are wonderful partners from 2B Cloud. I shared the link to their site in our check-in, a great company, so check them out as well. And take care, everyone.
Thank you very much.
Thank you, everyone. Have a good morning, afternoon, and evening, everyone.